Thank you very much, Dennis, for giving me this opportunity to give a tutorial that will give an introduction to Scikit-learn, which is a machine learning library in Python. So here we are basically having a continuous series of Python tutorial where we already had 3 tutorials. And I'd like to give an overview of what we already had, because the tutorial that I will be giving today is solely based on Python. So it's good to know that what we have already covered, and then it maintains a flow. So in first tutorial, a scientist or engineer has covered the basics of Python, that covered the data types, lists, and strings in Python. Then we have seen a tutorial that describes the control flow statements and function statements in Python. In the third tutorial, we have seen the manipulations that we can do using some advanced modules available in Python, which are pandas and NumPy. And then also in this journal club, we had another tutorial that gave an introduction of visual programming with Orange, which is also Python based. So all these videos are available in YouTube. And today what I will be showing is Python programming with Jupyter Notebook using Scikit-learn. So this is, I guess, the most advanced part of the tutorial. It will be completely focused on machine learning, like how to do machine learning using Scikit-learn. So from machine learning perspective, it's basic, but if you consider like the overall Python programming, then it's quite advanced, but I hope it will be very useful. So I'll start with some basic features of Scikit-learn. Scikit-learn is very simple and efficient for data mining, analysis, and modeling or machine learning. So I just want to give a little bit of more information here. That is, Scikit-learn covers vast areas of machine learning, like many different types of algorithms. So it's really not possible to learn all about Scikit-learn in one tutorial, but what I will be really trying to do today is to teach like how to use it, so that Scikit-learn is very well documented, so anyone can like go to their documentation and use it for purpose. All right, so this Scikit-learn library is built upon SciPy, which is basically scientific Python. And here I want to stress one information, that SciPy is based on C compiler, and that's the reason scientific Python or Scikit-learn is so fast. So Scikit-learn has many kits inside it, and those kits are, first of all, NumPy, which is n-dimensional array package of Python, SciPy, which is fundamental library for scientific computing, matplotlib, which is a visualization tool, IPython, which is enhanced interactive console, then SymPy, which is symbolic mathematics. So this is basically is coming from computer science. So it can do operations like double AND, double OR, and etc. And definitely for the data structures and analysis, pandas. All right, so from where Scikit-learn came? So it was initially developed by David as a Google Summer Code project in 2007. So he is now a software developer in Enthoughts. Then later, Matthew Brusher joined the project and started to use it as part of his thesis work. In 2010, INRIA got involved, and the first public release was published in late January 2018. And now the project has paid sponsorship from INRIA, Google, Tiny Cruise, and Python Software Foundation. So you can see that the overall age of Scikit-learn is approximately 7 years or 8 years, and it has around 10,000 citations. All right. So how to install Scikit-learn? So Scikit-learn requires Python. It can be 2.7 or 3.3. It requires NumPy and SciPy. So how to install it? If you already have NumPy or SciPy installed, then you can just do pip install Scikit-learn. Or if you want to do it with Anaconda, which is the complete package for Python, softwares, you can do conda install scikit-learn, or conda update scikit-learn, or conda remove scikit-learn. So here I have a little bit of typos, so you can imagine it will be just scikit-learn. All right, so before I start doing machine learning using scikit-learn, I want to introduce like what is machine learning or statistical modeling. So fundamentally, it is like collect data and then extract knowledge from the data. So you'll have n samples, which is like n number of rows, and you have m number of properties or features, and then now predict the properties of that unknown data. So here are the fundamental steps of statistical modeling. So you have data, and then you collect the data, you mine and process, and then here is your input space. And you can see this is annotated data. That means it's labeled data, and some data are of orange color, and some data is like of blue color. And then you do scientific computing or mathematics, and then you have your feature space. So you transform the data into a feature space, which is here is two-dimensional, and this is the properties. And so you can imagine that this data set has two features. And then you do a machine learning or modeling to draw a separation plane, which is the decision boundary. If you want to do the classification of this data into two classes, then this is your decision boundary. And there are many, many algorithms out there to draw this decision boundary, both linear and non-linear. And then this is a very, very important part of developing a statistical model, that you have to properly evaluate to have a robust model. So you have to do blind test, either by cross-validation or by using an independent test set. So you can see that here the data is different, which is represented using triangle dots, and then how this decision plane can classify this data, you have to evaluate by number of misclassification and number of correct classification. So this is the performance evaluation part. Okay, now what are the machine learning thing that we can do using scikit-learn? So we can use supervised learning. Supervised learning is a learning process when the input data comes with a label. That's the example that I have shown you just before, just in the other slide, that the data comes with label, and we want to predict or classify the data. And the variable that we want to predict or learn about can be discrete, and then we call it as classification problem. And if the variable is continuous, then we call it regression problem. And the data can be unsupervised. So the data comes without any target variable. And then we would like to do clustering or density or distribution estimation or manifold learning or dimensional tree reduction. So that's called unsupervised learning. So classically, unsupervised learning is much more complicated than supervised learning. And then we can do some steps that can be called as pre-processing steps if you consider data, or model selection steps if you consider like algorithm selection step. So we can do comparing or validating or choosing parameters and models, and we can do feature extraction or normalization. So this is important when you have data maybe with missing values, then you can do imputations. And then if you have a choice of multiple algorithms, and then you want to come up with a robust algorithm and which is eligible for this, which is best for this application, then you can do some model selection thing. All right, so basically here I will stop my presentation. I'll do some hand-on tutorial, and this is the last slide where I would like to show you this cheat sheet, which is available in Scikit-learn website, which I really love that they here kind of summarize the facilities that they have in Scikit-learn, and they classified it into like classification algorithms. They have regression algorithm and dimensionality reduction algorithm, and into clustering algorithms. So this is really a nice like kind of roadmap for someone who doesn't know about Scikit-learn. All right, so with that, I will now switch to Anaconda. Okay, so this is the Anaconda navigator from my machine. From here, so I'm going from very early step to show you all the steps. So I'll launch Jupyter Notebook from here. So here I have my directories in my machine, and I would like to go to a specific directory from here. All right, and now I want to open interactive session for Python. So this is the Jupyter Interactive Jupyter Interactive notebook, and here I'm naming this notebook as Python tutorial 4. Okay, so give me a second. All right, so this is something that has already been covered in the earlier tutorial. Whenever we do something in Python using a library, we have to load that library. So that's the thing that I will do first, that I will do from Scikit-learn input data sets. And I would also like to import pandas as PD and import numpy as NP. So this is like usually people do, like call pandas as PD or numpy as NP, but you can use any name here. So okay, we will learn it. So now I have the Scikit-learn and pandas and numpy here. Here you can see that I have imported data sets. So Scikit-learn has some built-in data sets there. So through data sets module, we can access those data sets. For an example, if I type data sets, then you can see that there are several data sets out there. So what I will do is I will load a data set called diabetes data. So here are several data sets here. So I would like to load this data set, and then we'll run it. So before observing or describing the data, what I will do is I will show you how we can convert this data into a data frame. So this is very easy. So we do panda pd dot data frame, and then we give so this is also one thing I want to show, that if you want to see the properties of the data, what you can do is you can type the name of the data set, and you can do dot and then tab to see that it has two properties, which is the data, which are the features, and the target, that is the variable to be predicted. So what I will do is I will apply machine learning here to predict this target variable using this data as features. So I will make the data frame using the data, and then I will also include a column called target, where I will assign the target variable of the data that I loaded. So also you can see that here I have used series instead of data frame, because series handles vectors. So while data is a matrix, a feature matrix, and the target is just a column vector. So I'm using series here. Okay, so I'll run it, and then if you want to see the data frame, then you can do head. So here is the data frame where you have 10 features, and something about this data here, you have 10 variables like age, sex, body mass index, average blood pressure, and 6 blood serum measurements. And this Y is the kind of quantitative measure for diabetes progression, and it has 442 samples. So what you can do is you can do DF diabetes and then shape, So here you can see that it has 11 columns and 442 rows. All right. So with that, basically, now I will do the machine learning task. So what you can see is this target variable here is continuous variable. So we will be applying regression. So before doing regression, we have to import or load the linear model if we want to do a linear regression. So that's what I'm doing now. That from Scikit-learn, I'm importing the linear model suites. And then if you want to see that what are the algorithms that are available in linear models, here you can see that you have naive Bayes, Bayes and elastic Nate, and many algorithms implemented here. Okay, so given that I have loaded the model and I have the data, so first step in developing machine learning model is to have our training set and test set. So for that, now I will convert my data frame into a matrix, and then I will split the data set into training and test set, and also into features and into target variables. So here I am loading the code for that. So I'll be a little bit explaining the code. So here I already had a data frame, and that I'm loading as a matrix because then it gives us a sense of having feature matrix and column vector as target. So it's good to have a matrix data here. And then I'm splitting my matrix data and taking all the columns but the last one, because we know that the last one is the target, as X, which is our feature. And then we are taking the last column as our Y, which is the variable to be predicted. And then I'm splitting each of these X and Y in a way that all but the last 50 samples goes into training, and the rest of the 50 go into the test set. Okay, so let's run this code. And then the next step is to load the classifier that you want to use to model this data. So here I will be using linear regression model. So the way to do is to load the classifier first. And the way to do is from linear model, I'll do tab and I'll search for linear regression. So we have a linear regression function implemented here within linear model. Then we can directly load as an object, which I named as regression, or REGR in short. So this is loading the classifier, and you can give some variables if you want to, like some parameters for the model. And if you want to use default parameters, then no parameter, nothing as an input. Okay. And after loading the classifier, now we have to fit the data using this object. So the way to do is develop a model. Okay, let's do it. Diabetes regression model, and then REGR, and then use the function fit. And we will fit this model using our training feature and our training label. And this is how it is a supervised learning. So you are basically fetching the label of the training data while you are developing your model. So this is why it is called supervised learning. Okay, so let's develop the model. Okay, so this is done. With the model, now what we will do is we will predict the data set, and this is the way to predict the data set. So this is our regression model, and then we are using a predict function, and we are feeding the features for the test data to have the predicted label. And notice that we already know the actual label, and now we have our predicted label. So now we can use some metrics to compute like how well our prediction is. So let's run the prediction. And now is the step of evaluating how the prediction is. So for that, we will have to import the metrics module from Scikit-learn, and then we can compute the R2 score that is implemented within Scikit-learn.matrix, and then we have to feed the actual label and the predicted label. And then if we learn, then the variance score, which is basically the Pearson correlation coefficient, as this is the continuous variable, it's 70%. So for perfect prediction, it's 1. All right, and if we want to see the coefficients of the linear regression, that is also possible. So here is the way to see the coefficients. All right, so and then with the value of the evaluation metrics, it's also nice to plot the results, and that is our next step. So to plot the data, we have to import the matplotlib, and then we have to write a code, which is this. Now a little bit of explanation. So we imported matplotlib as PLT, and then we initialized a figure. Then we are basically doing a scatter plot of the observed values and the predicted values. Then we are fitting a line, which is the original values, that is the test of the test data set, and then we are doing some labeling and etc. Let's run the code, and here is the plot. So here you can see is the observed versus predicted plot and the line that is fitting. All right, so with that independent so here what you could see that what we did is we split our data set into two sets as training set and test set, and then evaluated, did a blind test using the test set. But what we can also do is we can do cross validation. So an example of the cross validation. Okay, before I go to the cross validation, what I want to show you that it's possible to save this image that you are drawing here, and this is the code. So you initialize a figure and then call a function called save figure, and this will be saved in your current directory. So if I run it, then in my current directory, now I should have a PNG file, which is this. Okay. All right. So here I'm pasting some codes for doing the cross validation. So here you can see that for cross validation, we have to import cross validation score and cross validation predict module, and then we have to fit a classifier, which is the regression again that I have done before. So when you do the cross validation predict, then you give your classifier that you want to use for the cross validation, then you give your data, and then you specify that you want to do 10-fold cross validation or 5-fold cross validation or any fold cross validation that you want to do. Okay, let's run this code, and this is the output of the cross validation. So the score matrix. So what it did is it did the stratified sampling, and it subsampled the data into 10 parts and combined 9 parts into the training data set, and you used the other part to test. So it repeated this step 10 times, and here are the scores, which is the R-square score, the Pearson correlation coefficient for each step. So what you can see is this is very normal that the cross-validation score is lower than the independent test score, because in independent test we have more training set, and here basically we're splitting the training sets to several folds, so we have lower score than the independent blind test. All right, so we can also plot the output of the cross validation. So here would be the code, and now you can see more dots because this has been repeated for 10 times. So this is the same way you can see the output of cross-validation. So with that, I think I have covered how we can perform regression using Scikit-learn, and now I will show you one example of how we can do classification using Scikit-learn. So here I will be first importing several modules. I will also explain it. So what you can see is I have imported several classifiers like support vector machine, random classifier, random forest, gradient boosting classifier. So these are all different classifiers that have already been implemented in Scikit-learn, and we can just call it and use it. So this is really fun. Okay, and there are some other things that I have imported. So I will be explaining step by step. Let's import it. And before I do this classification example, what I want to tell is here I will not be loading any data set, but I'll be creating a data set. And the way I will do is there is a function called make classification that with which I can just generate a sample data set, for an example, 5,000 rows and using 500 features. And then we can do a test, a training test split automatically by calling this function, which also I have imported here. And I can mention that the test size will be 25% of the full data. So let's run it. Here I have my data now. And now I will perform a classification using SVC, which is support vector classifier. And I am mentioning that the kernel of the support vector machine classifier will be linear. And here I'm giving a C value, which is basically penalty value. So if you know about support vector machine classifier, then you would know what this parameter is. But if you don't know, that is also okay, because we can just change it and like do some tuning of the parameter and have our classifier ready and robust for the application that we have. So as you see, I have first loaded the classifier object, and then I have fitted my data, like the trained data, both the feature and the label, and then also have predicted. So here you can see that previously I was first fitting and then predicting, but here I'm doing everything in the same line. So I'm just showing different ways to do the same thing. So here I will run the code, and what you can see here that this dot was like solid. That means the program was running, but now it's again open. That means the program is completed. So now for evaluating a classifier, which is like a binary classifier, like this way, what we can draw is we can draw a confusion matrix. So a confusion matrix is basically the true labels of the class and the predicted labels of the class, and the kind of counts, like how much of the true class you have actually predicted as true, or if you have predicted as false. So it's like a confusion matrix of true positive, false positive, true negative, and false negative. So what we can do is we can import confusion matrix from Scikit-learn. So from Scikit-learn metrics, we are importing confusion matrix, and then we are drawing the confusion matrix with using our actual test data and predicted test data. All right, so here is the matrix. So, but what I want to show you is I want to draw a nice picture of the confusion matrix, but not in this way. So I have a small code for that. I will paste the code here now. So this is a very simple code where I'm just visualizing these values, but in a nicer way, which is this. So here I can explain it in a better way. So the data that I created for this classification purpose has two labels, which is 0 and 1. What you can see here, we had 579 plus 56 number of 0 labeled rows, and of which 579 have been predicted as 0. So this is true prediction, but this is a false prediction. And this is true negative, but this is false negative. So these are the combination of these two diagonal values are the total false prediction by this classifier, and the combination of this diagonal values are the total true predictions by the classifier. All right, so with after drawing this confusion matrix, one very exciting thing in machine learning is to draw what is the area under the reciprocal operating curve. So that is area under the ROC curve. So here, basically, I will run a bunch of classifiers on this data, and then I will have the predicted output, and I will show you how we can draw a ROC curve with the output. So I am fetching the codes here. So this is the code. So here what I'm doing is I'm defining an array of different classifiers. So first classifier is the logistic regression with a penalty type, a different penalty type, and then L2 logistic regression with a different penalty type. So these are all different machine learning algorithms which are already implemented in a very nice way, where you can provide different parameters. And then logistic regression algorithm, and then random forest classifier, and gradient boosting classifier. And then what I will do is I will fit my data using all those classifiers, and I will have output. So this is here I will be showing you how we can see the F1 score. So F1 score is a harmonic mean of precision and sensitivity. So this is a very robust evaluation metric if you want to evaluate a binary classifier. So let's run this code, and it will take some time because it is fitting the data into 5 different classifiers here. So you can already see that 95% F1 score here, which is very good. 95% here, 95%, 94, and I think it's working on GBC now. Okay, while it is feeding the data, let's do something else. So this is interesting. So you can also see from here that gradient boosting classifier is the best classifier for this application. So you can really quickly evaluate which classifier is the best classifier. So here I'll be separately running the classifiers one more time because it will give me a way to predict the probabilities. So this is also one thing that to draw the ROC curve, we need not the predicted class, but also we need to assign the probabilities of this predicted outputs. So we have to predict the probabilities. So let this one to finish. And let me copy this code here. So here you can see that I have independently loaded gradient boosting classifier, and then feed the data random forest classifier, and then I have feed the data, then logistic regression classifier, and then I have fitted the data. And with each of these module, I have called a function which is predict proba, and which basically assigns real value probabilities to the predicted class, so that we can draw the ROC curve. So we will run this code, and then a small fragment of code for drawing ROC curves. So the ROC curve will range from 0 to 1, 0 to 1 in both the x-axis. And as you know that the ROC curve is basically the rate of false positive and true positive. So I have always fitted the FPR is false positive rate and TPR is true positive rate. So FPR and TPR from each of these models. Now if we run it, then here is our ROC curve. So as GBC was the best classifier here, so you can see that it is approximately like almost perfect here. Now what we can also do is, if we want to zoom in the only the informative part of the ROC curve, then we can just change the limit, the x limit and y limit, and then have a better visualization. So this is what I'm gonna do. I think this is the last part of my talk. If I run this code here, only difference is here I have defined that the x limit should be 0.0 to 0.4 and the y should be 0.6 to 1. And this is the zoomed out version of the ROC curve. So basically, this is all that I wanted to show, that that how can we do the regression and classification using scikit-learn. So I think you have got the steps. So the usual steps is have your data ready, and if you want to do some pre-processing like imputation of the missing values, do that, and then split into train and test, then load the models, available machine learning algorithms in scikit-learn, and then fit your data. You have your predicted values, and then use the metrics that are available inside sklearn.metric and do the evaluation. Yeah, so this is the introductory part of scikit-learn. Thank you very much. I hope I am able to give you like a very brief overview of how to develop machine learning model using scikit-learn. Thank you.